Welcome everybody once again. So this is our 7th class for module 4. Today we will see a few problems. We will try to solve a few problems on the most economical trapezoidal sections in open channel flow. So first problem is, already we have seen in the previous classes the conditions for most economical trapezoidal sections. So we will use those conditions for solving the problems. So the first problem is, a trapezoidal channel has side slopes of 1 horizontal to 2 vertical. So we have a trapezoidal channel. Okay, we have a trapezoidal channel. It is given the side slopes is 1 horizontal to 2 vertical. So side slope is 1 horizontal to 2 vertical. And the slope of the bed is 1 in 1500. So the channel's bed slope is 1 in 1500. The area of the section is 40 meter square. So the given data are horizontal is to vertical. The side slope is 1:2. I is given as, that is slope of the channel bed is given as 1 by 1500, 1 in 1500. Area of the section is given as 40 meter square. So area is equal to 40 meter square. Find the dimensions of the section. We need to find what is B and what is D. Our aim is to find the breadth of the trapezoidal channel section, the depth of flow of the trapezoidal channel section. So let us imagine the depth of flow of water is up to this. So depth of flow is taken as small d. The bottom width of the channel section is taken as small b. Okay. So B is equal to bottom width of the trapezoidal channel. And small d is the depth of flow. Now, the condition is it should be most economical. Determine the discharge of the most economical section if C equal to 50. So Chassis constant C is given as, this is Chassis constant C is given as 50. We need to find what is Q, what is the discharge for the most economical section. So now we know if the bottom width is B, see if you extend this, if you are drawing perpendicular lines, we know this distance is equal to ND, right? This is also equal to ND. So top width is, so we know top width is equal to B plus 2ND, right? So top width is equal to B plus 2ND. So B plus ND plus ND, it is B plus 2ND. Now what is ND? How much is this? This ND is equal to, see if it is 1 horizontal, it is 2 vertical. Okay. 1 horizontal means 2 vertical. So if it is D vertical, I will write like this. ND means horizontal, right? Horizontal by vertical is equal to 1 by 2 is equal to, now horizontal is ND, the vertical is D. So how much is ND? ND is equal to, equate these both, we get ND is equal to D by 2. Okay. So ND is equal to D by 2. So from which we get our N is equal to 1 by 2. Now, we know the condition for most economical trapezoidal section. So, for most economical trapezoidal section, one condition is half of the top width. Half of the top width is equal to one of sloping side, one of the sloping side. We know, see the sloping side. Now we know what is top width. The top width is b plus 2nd. And nd is equal to d by 2. So b plus 2nd is equal to b plus 2 into nd is d by 2. So we get b plus d. Okay. So top width is equal to b plus d. Now we need to find what is the sloping side. So we'll take this as equation number 1. So how will we find the sloping side? We can take this triangle. Let this be A, B, C, D, E. So take triangle ECD. We get the sloping side CD is equal to square root of EC square plus ED square. So this is nothing but square root of EC is D square plus ED is ND the whole square. ND is D by 2. So D by 2 the whole square. Okay. So we get we can take d square, d out. So we get 1 plus 1 by 4. So this is equal to d into square root of 4 plus 1, 5 by 4. Now we will substitute this in equation number 1. So we get half of the top width, half of the top width. The top width is b plus d. So half of the top width is b plus d by 2 is equal to one of the sloping side is d into square root of 5 by 4. Okay. So this is one equation. So we will take this as equation number 2. Now, area is given as 40 meter square. Right? So what is area? We know area of the trapezoidal channel is equal to half into the summation of the widths, right? So B plus top width is B plus D. B plus D into the depth of flow, that is D. So area is given as 40. So 40 is equal to D by 2 into 2B plus D. From which you can write 80 is equal to 2BD plus D square. From which you can write 2BD is equal to 80 minus D square. And from this we can write B in terms of D. So B is equal to 80 minus D square by 2D. So substitute this B in equation 2 so that the only unknown is D. Okay, substitute this value for B in equation 2. So the only unknown is D. So substituting, you will get the answer as D is equal to 4.8 meter. So if you get D is equal to 4.8 meter, you can substitute D in this equation in B. So B is equal to 80 minus D square by 2D. So substituting, you will get B is equal to 5.933 meter. Now you can find the wetted perimeter M. The condition for the most economical trapezoidal section, wetted perimeter M is equal to D by 2, from which you get M is equal to 4.8 by 2. So 2.4 meter. Now you can use the formula Q is equal to area into velocity. Area into velocity is C into root of Mi, the Chessie's formula. So value for C is given as 50. M we have found it as D by 2. The bed slope I is given as 1 by 1500. So substituting, you will get the discharge Q is equal to 80 meter cube per second. Okay. So now we will move on to our second problem. So our second problem is a trapezoidal channel has side slopes of 3 horizontal to 4 vertical. So we will draw the trapezoidal channel. So the side slope is 3 horizontal and 4 vertical. And the slope of the bed is 1 in 2000. Determine the optimum dimensions of the channel if it is to carry water at 0.5 meter cube per second. So Q is given as 0.5 meter cube per second. We need to find the optimum dimensions. That is, what is B and what is D. Also, Chessie's constant C is given as 80. So as usual, so our depth, let us take the depth of the channel as D, the bottom width of the channel as B. So we will draw vertical lines from the bottom width. So this is ND, ND, and this is B. So this ND, how will we find ND? We know horizontal by vertical is equal to, horizontal is given as 3, vertical is given as 4. So horizontal is ND and the vertical is D, right? Horizontal is ND and the vertical is D. So from which we get ND is equal to 3 by 4D. So that is what we needed, right? So N is equal to D, 3 by 4. N is 3 by 4. 3 horizontal, vertical. So N is nothing but horizontal is to vertical. Horizontal by vertical is called N. So we get ND is equal to 3 by 4D. So let B be the bottom width. So top width is equal to B plus 2ND. So we get B plus 2 into ND is 3 by 4D. So we get B plus 3D by 2. Now we will use our conditions. For the most economical trapezoidal channel section, we know half of the top width is equal to one of the sloping side. So half of the top width is B plus, so we will write this as 2b plus 3d by 2. So 2b plus 3d by 2 into 1 by 2 is equal to sloping side. Sloping side, we know the formula is so we will find what is the sloping side. So the sloping side is equal to, let us take this as A, B, C. So AC is equal to square root of AB plus BC. AB is D plus BC is ND. ND is 3 by 4 times D. So from which we get okay. So it is a square, right? D square plus 3 by 4 D the whole square. Okay, we will write it as. So square root of D square plus 9D square by 60. So from this, we will write B in terms of D. You solve it. Okay, you can do this. Solving this, expand this, you will get B in terms of D. So we get B is equal to D. See, if you solve this equation, you will get B is equal to D. Now, we know for the most economical trapezoidal section, another condition is the wetted perimeter is equal to D by 2. Now, the discharge is given. So, we will use Q is equal to area into velocity. So, area into C into root of mi. So, Q is given as 0.5 is equal to area multiplied by C is given as 80 square root of m is D by 2, right? M is D by 2 into I is given as 1 in 2000. 1 by 2000. Okay, we will take this as equation number 1. Now, we know what is the area. So, we know area of the trapezoidal section. We know area of the trapezoidal section is equal to half into, okay, I'll write it here. Area is equal to half into the summation of the breadth, that is B plus top width is 2B plus 3D by 2. Top width, okay, bottom width, top width into the depth of flow D. So from which we get, see, you substitute B is equal to D. B is already, we have obtained B equal to D. So substituting B equal to D, we get area is equal to 1.75 D square. Now we will substitute this in equation number 1. So we get 0.5 is equal to 1.75 D square into 80 into square root of D by 4000. So the only unknown is D, from which we get D is equal to 0.55 meter. Now B is equal to D, so B is also equal to 0.55 meter. So anything else we need to find? Determine the optimum dimensions of the channel. That's all. Okay. Now we will move on to our third problem. So third problem is a trapezoidal channel with a side slopes of 1 to 1 has to be designed to convey 10 meter cube per second. So one horizontal, one vertical, 1 to 1. Side slope is 1 to 1. Has to be designed to convey. So Q is equal to 10 meter cube per second. Okay. At a velocity is given as 2 meter per second. So that the amount of concrete lining for the bed and sides is minimum. That means most economical. Calculate the area of the lining required for 1 meter length of the channel. Okay, so if Q and V is given, from this we can find what is A. So Q is equal to area into velocity. So from which we get area is equal to 5 meter square. So 10 by 2 we get 5 meter square. Okay. Now we will take the depth as small d. So this is ND, ND and B. This is B. So we know, let us find what is ND, right? So we know horizontal by vertical is equal to 1 by 1 is equal to, if the vertical, that is ND by horizontal ND, vertical depth is small d. So from which we get ND is equal to D. That means our N is equal to 1. N is nothing but horizontal by vertical, right? So N is equal to 1. Now, bottom width is B. Our top width is equal to B plus 2ND is equal to B plus ND is D, so 2D. Okay, so top width is B plus 2ND. Now we know for the most economical trapezoidal section, half of the top width is equal to one of the sloping side. So half of the top width is B plus 2D by 2. B plus 2D by 2 is equal to one of the sloping side. Sloping side. So we will find it. We will draw vertical line. We will take this as A, B, C. So AB is equal to square root of AC is D square plus CB is ND. ND is D. D square. So D square into root 2. Sorry, not D square, it is D into root 2. So from which we get B is equal to 0.828 D. Now we can substitute in area, in the area equation. So area is half into summation of the top and bottom width, that is B plus, top width is B plus 2D. So substitute B is equal to 0.828D in the area. We already know area is equal to 5 meter square. So we get 5 is equal to half of 2b plus 2d. So we get half of b plus d. Now substitute b is equal to 0.828d. We get d is equal to 1.644 meter and b is equal to 1.369 meter. Now our aim is, you are asked to find the area of lining required for 1 meter length of the channel. So area of lining required for 1 meter length of the channel. So for 1 meter length, how much lining is required? So lining required will be for this length, right? So first of all, we need to find the wetted perimeter. So wetted perimeter into 1 meter length. So area of lining required for 1 meter length of the channel is equal to wetted perimeter multiplied by length. So here it is 1 meter, right? So what is our wetted perimeter? Wetted perimeter is this sloping side plus b plus sloping side. So sloping side is d root 2. So 2 into d root 2. So 2 sloping sides. So 2 into d root 2 plus b. So this is our wetted perimeter multiplied by length is 1 meter. So you can substitute the values for d and b. We get the area of lining required for 1 meter length of the channel as 6.047 meter square. So we will move on to our fourth problem. The fourth problem is an open channel of most economical section having the form of a half hexagon with a horizontal bottom is required to give a maximum discharge of 20.2 meter cube per second of water. The slope of the channel bottom is 1 in 2500. Taking chassis constant C is equal to 60, determine the dimensions of cross sections of the channel. You can do this. See, I will give you only one clue for here. See, this is given as half hexagon, right? You know what is a hexagon. See, this is called a hexagon. See, that means here every angle will be 60 degree. So the internal angle is 120 and the external angle is 60 degree. So this angle is 60 degree. And see, if this angle is 60 degree, this is 90 degree. That means this angle is 30 degree. So that means you will have vertical one, horizontal one. So with this clue, you can continue your problem. You can do this as homework. Okay. So you take horizontal by vertical is 1 by 1. This angle of the side slope making with the horizontal is 60 degree. Remaining as usual. So side channel bed slope is given as 1 in 2500. Chassis constant is given as 60. So you can continue. You will get I will give you the answer. The answers are D is equal to 2.852 meter and B is equal to 3.293 meter. Okay, we will move on to our fifth problem. Fifth problem is a trapezoidal channel with a side slope of 3 horizontal to 2 vertical has to be designed to convey 10 meter cube per second at a velocity of 1.5 meter per second, so that the amount of concrete lining for the bed and sides is minimum. That means it is open channel flow. Find the wetted perimeter. You know how to calculate. Slope of the bed. You need to find what is I. What is P, wetted perimeter? That is 2 times the sloping side plus B. That will be your wetted perimeter. Find the slope of the bed. Find what is I. The only difference is here it is given as Manning's constant. Manning's constant is given as 0.014. We know Manning's formula is an empirical formula used to find the Chassis constant, right? So the formula is C is equal to 1 by N into M raised to 1 by 6. M is the wetted perimeter. Sorry, hydraulic mean depth. M is hydraulic mean depth. We know for the most economical trapezoidal section, hydraulic mean depth is equal to D by 2. So use this formula, find what is C, then substitute. You will get, you need to find the wetted perimeter. Okay. So the only difference is using the Manning's formula to find the Chassis formula. So you will get, I will give you the answer. See, discharge is given, velocity is given. So your values will be area is equal to 6.67 meter square. You will get small d is equal to 1.78 meter, that is depth of flow. Our breadth will be equal to 1.07 meter. The wetted perimeter will be equal to 7.48 meter. And the slope of the bed I will be equal to 1 by 1729.4. We will move on to our last problem. So the last problem is a power canal of trapezoidal section has to be excavated through hard clay at the least cost. Least cost means most economical trapezoidal section. Okay, most economical. Determine the dimensions of the channel given the discharge equal to 14 meter cube per second, bed slope 1 is to 2500 and Manning's constant N is equal to 0.020. Now, see, since the excavation it is given, it has to be excavated. Okay. So for excavation of the canal at the least cost, the trapezoidal section should be most economical. And here the side slope, that is the value for N is not given. We don't know. We do not know. See, we do not know what is H and what is V. We do not know. If we don't know the horizontal is to vertical, if we do not know the ratio of the side slope, you have to use the condition for best side slope for the most economical trapezoidal section. So we know the condition for best side slope for the most economical trapezoidal section is N is equal to 1 by root 3. Okay. So horizontal is to vertical will be equal to, that is N is equal to 1 by root 3. So I didn't give you this value in the previous class. See, the condition is this theta will be equal to 60 degree. Now the difference between this problem and previous problem. See, previous problem, is it this problem? No, fourth problem. 5. See, fourth problem you can see, this is hexagon. This forms hexagon. That means these are equal. See, this is equal. These sides are equal. Okay. That is why it is 1:1. Now here, for this problem, we do not know. We don't know what is B and what is D. This may be equal or this may not be equal. But theta is equal to 60 degree. So if theta equal to 60 degree, when you use the condition for most economical trapezoidal section, that is B plus 2ND by 2 is equal to D into root of n square plus 1. And when you substitute the value for wetted perimeter, you will get the condition n is equal to 1 by root 3. Okay, so you use the condition n is equal to 1 by root 3. That is, horizontal is equal to 1 and vertical is equal to root 3. So with this you continue the problem. You will get the answer as D is equal to 2.605 meter and B is equal to 3.008 meter. So that is all for today. Thank you. See, it is 1 by root 3 because we don't know how much is the depth. The depth may vary. Okay, the depth varies. Depth and breadth is not the same. For the previous problem, that is for the half hexagonal problem, the breadth and depth remains the same. That is why the horizontal to vertical ratio was 1:1. So here for the most economical side slope, the value for n is equal to 1 by root 3. So thank you for listening. Thank you.